or just conceptual stuff or anything you don't understand that want to talk about before we get started here? Be happy to field some of these guys. Sure. So when we have like one of these standard position angles. Oh, thank you. I pressed the button, I thought. Maybe I didn't. I'm glad you spoke up right away, though, and didn't let me sit there go blathering on for a couple of minutes and then be like, we couldn't see anything you just were talking about. Be like, what did didn't somebody say anything earlier? Okay. Shh. So let's say we have a standard position angle. Let's say our standard position angle is like, I don't know, like 200 degrees or something. So to draw that, I start by writing in my initial side, and then I'm going to rotate counterclockwise since it's a positive angle, starting at the initial side. So I know up to here is 90, this is 180, that's 270. So I'm going to be landing somewhere in here, closer to the 180 than the 270, right? So an angle that's coterminal to that, say this one, is any angle that's got a different measure whose terminal side lies in the same direction. So for example, negative 160, so this is like negative 90, this would be like negative 180, so negative 160 would lie somewhere in between those, closer to the negative 180 than to the negative 90. Is that okay? So if I want to find two angles that are, if I want angles coterminal to one of these, I can get that by just adding or subtracting 360. Notice that these angles are coterminal, and 200 minus 360 is negative 160. So to find another angle that's coterminal, you can just repeatedly add or subtract 360, and you'll keep generating angles that are coterminal. There's infinitely many angles that are coterminal to a given angle, because you can just keep adding or subtracting 360. Everybody's okay with that? How does this change if we're given an angle in radians? So let's say we have 7 pi over 4. So this is 90 degrees, but in radians, that's pi over 2. How did I get that? I multiplied by pi over 180 and then reduced, right? Got to remember that. So that one's pi, that's 3 pi over 2, and that's 2 pi. Well, 7/4 is like 1.75. So 1.75 comes somewhere between 1.5 and 2. You guys see that? So it's going to be somewhere in here, about halfway. Everybody's okay with that? So another angle coterminal to this one might be where we go around one time before settling back there. What would that look like algebraically? Well, if I do one full rotation, that's 2 pi that I'd be adding to that and then doing that part. So adding 2 pi is just like adding 360. Just if your angle measures in radians, we use radian measures, and if we're in degrees, we use degree measures. So if I wanted to add those two together, what do I need to do? Make a common denominator, very good. So like I can do that 4 over 4. So that's 7 pi over 4 plus 8 pi over 4 equals 15 pi over 4. So that would be the blue angle that's coterminal to the red one that we drew. Aiden, is this helping? So the big takeaway, if I want to find an angle that's coterminal to another, I can just, if my angle's in degrees, I'm just going to add or subtract 360. That'll give me another angle that's coterminal. Each time I do that addition or subtraction, gives me a new angle that's coterminal. I can do this for as long as I want to generate as many as I'd want. If we're in radians, instead of adding and subtracting 360, we add or subtract 2 pi. That's the summary there. Olivia, you're making some faces and look like there's a hesitant hand.
Does it matter if you add or subtract?
Not really. Either way, you're going to get a coterminal angle. You may end up with an angle that's positive or negative, and depending on the directions, maybe they ask for, one or the other. But no, not really. If all you need is a coterminal angle, it doesn't matter. Aiden, did that clear things up a little bit for you? Okay. So it should be, they're relatively easy to find coterminal angles, right? Like if we have, 119 degrees and I want something coterminal to that, I add 360, there's one. If I want another, I can just add 360 again. There's one. And then just keep adding, and I'll keep getting new coterminal angles. Do that as many times as I want, depending on the directions. If they're asking for 1 or 2 or 10, just keep adding. Or you could have subtracted, it didn't matter. That would have been fine too. I usually like adding because the subtracting sometimes gets harder to do in your head. Just marginally, but hard enough to do in my head that if I have a choice, I'm just going to pick add. Because why? You know what I mean? What else do you guys want to talk about? Yeah, praise.
Radians to degrees.
Oh, radians to degrees, great. So if I want to go radian to degrees, we're going to multiply by 180 over pi. And then to go the opposite way, degree to radian, we multiply by pi over 180. That's your key conversion factor for this chapter. If there's one conversion factor to remember, this is it. And usually I think it's really easy to remember which one goes where, because if I have 45 degrees here, I know the degrees has to be in the denominator. Or if I have, 7 pi radians here, I know the radians has to go in the denominator. So it's easy to remember which way the numbers need to go, because it's just going to match up with the units in my problem, just like in chemistry class when you do your unit conversion there. If you've taken chemistry, which I think a lot of us probably have. So that's one thing that you definitely would want to have memorized or whatever for, ideally now, but certainly by the test. That'll be something that comes up over and over again that you'll need to have to convert. What other formulas did we have this chapter that would be useful to have on hand? Yeah, Boyd.
Well, I guess it's not really a formula, but the SOHCAHTOA thing.
Okay, for sure. because we did do some right triangle trig there in section 2.2. Yep. For sure, if you didn't already have that memorized and can't do SOHCAHTOA problems, you'd want to make sure you can do that. And there's one other formula here. S is equal to r theta, where we're in radians. And if we're in degrees, if theta's degrees, what do we have to do? We just tack on the degree to radians conversion factor at the end. And that would be our formula in degrees. That's for like the arc length. Right, so depending on whether your formula or whether your problem was giving you your angle in degrees or radians, I would choose my formula differently. Or I could just like, whatever the angle I'm given, just convert it to radians and always think about using that one. That's kind of what Mr. Kulik does, is he just has the one formula and he just converts everything to radians. Because it feels like less of a hassle, because I already know how to convert degrees to radians. You know what I mean? So this was like 2.1 stuff. This was like our 2.2 stuff. What was in 2.3? That was like drawing standard position angles. And coterminal. That was like all we did in section 2.3. Just talk about drawing pictures, how to draw those standard positions, and define things at coterminal. And that's as far as we got before the homework quiz, right? So anything after that, the unit circle stuff or the non-right triangle definitions for sine, cosine, and tangent, don't have to worry about for today. Will you need those things later? Oh yeah, definitely. But this would all be good stuff to put on like your half sheet for the test. You always get a half sheet for the test. That's not a one-time thing, that's an all-the-time thing. You know? It's pretty sweet. So, anybody else? Again, it's fine to do specific stuff. It's fine to do general stuff like we've been doing here. Okay, if you guys don't got anything, I'm ready to go. Are you ready to go? Yeah, Boyd?
Could you do the revolution conversion?
I can, but you don't have to do it today. So if you don't, do you still want to see it? You'll save that for next time. Which again, I'm cool with. Yeah, good to go.